Lesson 12.4, volume of prisms and cylinders. So we were doing surface area, now we have moved on to volume. Volume is the amount of cubes, the number of cubes you could fit inside a polyhedron, or inside of a three-dimensional shape. Area is how many squares you could fit within the two-dimensional shape. Volume is how many cubes fit in a three-dimensional shape. For a prism, it's the area of the base times the height. For a cylinder, the area of the base is circle, so it's pi r squared times the height. So find the volume of this figure. What we're going to do is we're going to cut it into two prisms. We have the top cube. So this one, I need a different color. How about this one here? So that top cube. Now its base is 1 by 1, and its height is 1. So its area of the base is 1 by 1, and its height is 1. For the bottom part, its base would be here. So it's 3 by 1, so that's its base. And its height is there, which is 2. So 3 by 1 by 2, which is 6. So it means the total would be 1 plus 6, or 7. How about this one? This one's a little bit more complicated. This is a triangular prism, but it has a hole in the middle. That square hole is cut all the way out through the center. All right, we're going to start by finding the base area. That would be the front. And so we'd find the height of this triangle. All right, you can see I've drawn kind of a red triangle on there. I want the height of that triangle. It's an isosceles, actually it's an equilateral triangle. So when I draw this, all the sides are 10. So the slanted side's 10. I drew my height straight down to the center, so it's going to hit directly in the center, and so that'll be 5. So we could use the Pythagorean Theorem. You can say 5 squared plus the height squared equals 10 squared. So 25 plus the height squared equals 100. Height squared is 75. All right, and you think, okay, what times we have to do the square root of 75? Square root of 75, well, let's see. 75 is 25 times 3. So I do the square root of 25 and the square root of 3, which gives me 5 square root of 3. All right, so the base area would be this triangle minus the square. So the triangle is 1/2 base times height. The area of a square is side squared. All right, so the base of the triangle is the 10, and we had the height of the triangle was 5 square root of 3, and the side of the square, there's 3. So 1/2 10, 5 square root of 3 minus 3 squared. Put that in your calculator, you get approximately 34.301. So now we can find our volume. The volume is the area of the base times the height. So I decide what's the height of the prism. Remember, height of the prism is perpendicular to the bases. It's the distance between the bases. This is actually the height of the prism, the 6 feet, because the bases are the triangles. The height is the distance between those bases. So it's the area of the base, remember that was the 34.301. Times 6, which is about 205.8 feet cubed. There are 150 1-inch washers in a box. Now a washer is one of these little flat round things that you put around the screw. When they're stacked, they measure 9 inches in height. The inside hole of each washer has a diameter of 3/4 of an inch. Find the volume of metal in one washer. So our base area, it would be right there. It'd be that little circle. So it's a circular hole, so it'd be the big circle minus the small circle. So area of a circle is pi r squared. If they're 1 inch, that means that that's a diameter. So that means the radius would be a half. And it says that this 3/4 is a diameter, so that means that radius is half of 3/4 or 3/8. Let's see. How do I get that? 1/2, 3/4, multiply those together. Across the top, 1 times 3. Across the bottom, 2 times 4. Alright, so I can fill in 1/2 for the big radius, 3/8 for the small radius. Subtract them. I need to find the height of one washer. The height would be our total height of 9 inches, but there's 150 washers that make that 9 inches. So it'd be 9 inches divided by the 150 to find out how high each one is, which is 0.06 inches. So our volume is the area of the base times the height, or 0.3436 times 0.06, which is 0.021 inches cubed. Cavalier's principle. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So think of that stack of washers. What if we tilted it sideways, so there's the first washer, and the next washer, and the next washer, and the next washer, and the next washer. But they have the same height. Just because I tipped them sideways, did their volume change? No, they still have the same amount of volume. There's still the same amount of metal there. That's what Cavalier's principle is saying. So find the volume. So this is an oblique triangular prism. The area of the base would be, it's a triangle, so it's 1/2 base times height. So I'll call this the base and this the height of the base. Be 1/2, 9 times 5, or 22.5. Our volume is the area of the base times the height. Now, that was of the base. This is the height of the prism, because the height of the prism is the distance between the bases. So it's 22.5 times 8, or 180 meters cubed. That's it. Have a good day.